This is the general reaction for an equilibrium constant. This shows the ratio of products to react with this is the general reaction in an equilibrium constant. This shows the ratio of products to reactions at equilibrium. However, you need to understand that this excludes pure solids and liquids, and this is only in the aqueous and gas phase counts. So this one, however, the reaction quotient looks just like this type of equilibrium, and it uses the concentrations at any point in time. That's the only difference. This one uses at any point in time. Here we have a reaction quotient. When you see here, if Q is less than equilibrium, that means the reaction is spontaneous. However, if it's greater than equilibrium, it's non-spontaneous. This shows actually that there's too many reactants. So I'll put here too many reactants, and R stands for reactants. So in this case, we need to create an equilibrium. So in this case, many make more products. And because of this, reaction will go forward. And here, there's an equilibrium already. So the reactants and the products are equal. This shows, in this case, that there are too many products. So in this case, too many products. P for products. And because there's too many products now, there's not enough reactants. So then we're going to go ahead and make more reactants. The same principle is applied in the Le Chatelier's principle, because it's all about creating that equilibrium once again. As you see here, kinetic products. It says it's higher in free energy than thermodynamic products and can form at lower temperature. It's fast products because they can form more quickly under such conditions. Kinetic products form faster because they have a lower activation energy. This makes it less stable with higher free energy, and it's favored at low temperatures and short times. So it's best at low temp and low times, so short times. Thermodynamic products, however, says lower in free energy than kinetic products. It's more stable and slower but more spontaneous. Why is it spontaneous? Because there's a negative G. So you see here, that shows spontaneous. Now we have here the Le Chatelier's principle. This is a bicarbonate buffer. When there's very low pH, that means that there is a possibility for metabolic acidosis, because this means acidic. When we have a low pH, we're talking about acidic, and then when we have a high pH, we're always talking about base. So then this could lead to metabolic alkalosis. So write that here. When there is a low pH, it's acidic, it usually means there's just too much of the hydrogens. And this is why respiration occurs, blowing off carbon dioxide, typically hyperventilation, right? You're breathing so fast, trying to breathe out everything. The reason why that is, it's to reduce the hydrogen, since there's too much of it. See how there's always some form of equilibrium? And then we have here a high pH. Now, there's not that much hydrogens. In this case, respiration lowers and traps carbon dioxide. Why is that? Because we're trying to gain H+. So, because of alkalosis, A compensation is done by hypoventilation, which is very low breathing.